Welcome all. Today we are going to discuss the second chapter of Microcontroller programming subject of Electronics and Instrumentation branch C18 curriculum SBTech Telangana. Till now, that means up to yesterday's class we have learnt about the basics of 8051 microcontroller, that is the function block diagram, pin diagram of 8051 with the explanation of each and every pin, and the register structure of 8051 microcontroller, that is the register banks available, general purpose registers, special purpose registers, and special function registers. Simply we call them as SFRs, and with the explanation of each and every register with the bit arrangements, right? And we have also learned about the internal memory organization of 8051, that is internal RAM of 128 bytes divided into three groups. The lower 32 bytes are register banks, and next 16 bytes of general purpose area, and 80 bytes of scratch pad memory. Sorry, the 16 bytes of bit addressable area. So why am I repeating everything? Because you need to recollect the previous chapter topics so that you could even understand the coming chapters easily. Now moving on to the second chapter, that is the assembly language and addressing modes. This is also called software part of this 8051, because till now we have seen the skeleton, that is what are the features available, the practical hardware part in the 8051. Now we are looking at the language, assembly language, how to write the programs, what are the instruction methods and instruction types, and what is the syntax to write a instruction and how they will be executed. Now moving on to the topic, the objectives of this second chapter are definition of bit, nibble, byte and word related microcontrollers, and define the terms of machine language, assembly language and mnemonics. We call it as mnemonics. And the difference, third objective is write the difference between machine level and assembly level programming. Next, difference between low level and high level languages. And after that, state the need for assembly level programming and need for an instruction set and instruction format of 8051 and illustration of these terms by writing some instructions, that is the examples. And next, classification of the instruction set of 8051. Next, 1 byte, 2 byte and 3 byte instructions of 8051. And after that we have addressing modes with reference to microcontroller, and then various addressing modes of 8051 and explanation with the proper examples. And last objective is need for bit level addressing. So the first topic is definition of bit, nibble, byte and word related to microcontrollers. Most of you have already learned these terms, that is bit, nibble and byte words in the digital electronic subject of your third semester or second semester. Now just recap, revise and remember those terms. So the definition of bit: a bit is a single binary digit, that is a base 2 digit, which can represent exactly two unique values, that is 0 or 1. So a single bit is a single binary digit with the base 2 can represent exactly two unique values, that is 0 or 1. It is the fundamental unit of digital information storage. So everything digital data is comprises of zeros and ones. So that particular 0 or 1 is called a single bit. Between single bit of information, that is single digit. So we can simply call it as a bit. No need to call it as a single bit. Directly we can call it as a bit only. Next is nibble. See the definition of nibble. A nibble, also sometimes spelled as nibble or nibble, is 4 bits wide, half the width of an 8-bit byte. The 4 bits are combinedly called as a nibble. It can represent exactly 16 unique values ranging from 0000 through 1111. It is 0 in decimal and in hexadecimal, to 15 in decimal and F in hexadecimal. Right? You know all these things because 4 bits means 2 power 4, that is equal to 16 unique values. And the next topic is byte. In the modern world, a byte is 8 bits. It is also known as an octet. Octa number 8 means, right? If you remember, octet. We can represent exactly 256 unique values. 256, 2 power 8, that is equal to 256 unique values ranging from 0 in decimal through 4 ones and followed by 4 ones. We have 255 in decimal. 2 hexadecimal, that is the base 16 digits, can be used as shorthand to represent a byte value. That is, we are representing this byte in terms of a hexadecimal number, then we need 2 digits only, right? In hexadecimal, the unique values in a byte range from 00 to FF. There is 4 zeros and 4 zeros represents the zeros in hexadecimal number system, and 4 ones and 4 ones can be represented in the hexadecimal as F and F. Next is word. A word is a 32-bit, basically the number of bits a particular computer CPU can deal with in one go. It is a 32-bit. Varies depending on the computer architecture you are using. Generally, if you see in every practical real world, that if you have a laptop at your home, you see the configuration, that is Windows X32 or Windows X64 bit. So that is the byte. Actually, the word here already in the point word is that bit. Basically, the number of bits a particular computer's CPU can deal with in one go. That is the it actually representing in the configuration of your computer, that is Windows X32 or 64. Okay. Next, if the number of bits is more in that particular configuration, that means the CPU is dealing with a higher data, there is more number of data at a particular time. That means it is dealing with the data more in a short amount of time. That means it is faster compared to the lower number of bits per full second. Okay, the more the number of bits, the faster the CPU. Next, the second objective of this chapter, define the terms machine language, assembly language, and mnemonics. When anyone wants to communicate to another person, then a language is followed. So, if we want to communicate with computer system, then we have to use computer language. The microcomputer programming languages can be divided into the following three types. Next, if you want to communicate with another person or another, even the animal, even with some, yes, we can communicate with the animal with the signs, symbols, signs, right? The sign language it can understand some of the animals. If you want to communicate with the children, though they don't know the language, but they can see our expressions. Okay. So like that we have to communicate with another person. That means there is a language, sign language or braille language and normal English language and your vernacular languages. We need one particular language to communicate with the other person. So same with the computer also. The computer will process the data, the arithmetic operations also will be done when we give the input in the understandable language of the computer. That means if we give the language in our daily life, that is the English, then it has to convert that particular language into a computer language, then only it can understand. So the computer programming languages can be divided into three types: machine language, assembly language, and high level language. The machine language and assembly language are considered as low level language. Low level language. First one, machine language. A program written in the form of zeros and ones is called machine language, also known as binary language, as only 2 bits are being used. That is the machine understandable language. Actually, zeros and ones, though we can understand, but it will be very tiresome and clumsy, and it will take more time to understand than our common tongue, that is the English or the other languages. The zeros and ones, if you write a particular coding of the computer program in zeros and ones only, then it is a machine language. The machine can understand these zeros and ones very effectively and fast, accurately compared to the humans, that is we users. So it is also called binary language because we will use only the 2 digits only, that is 0 or 1. To write a program in machine language, program has to memorize the hundreds of binary instruction codes for a processor. Right? If you want to write the instructions or code in this machine language, then we have to remember what each and every instruction in our high level language, that is the common language we humans use, has to be remembered in the machine language. That is for each and every instruction. Example, move a comma b, move r 0 comma r, add a comma b, or multiplication a comma b, null a comma a b. Because those instructions null a b add a comma b we can easily remember because those are in our language. It is in the mnemonics of course they call mnemonics, but they are easily understandable to the human, that is the user. But if you want to remember that particular instruction add a comma b in the machine language, then you need to remember at least a 3 byte of data. It is 3 into 8 24 bits. You have to remember in the sequence 0 0 0 1 1 1 like that. You have to remember instead of saying add a comma b, you have to say the 3 byte of data. So which one is easier, the mnemonic form or the machine language? Obviously it is the mnemonic form for humans, for us for the users to understand it, to remember it, to easily reproduce it. Okay, so like that we need to understand. This task is difficult and error prone, right? The humans cannot remember the entire 3 byte data for each and every instruction, or if we do remember, then there is a problem of error prone because there is only 2 digits, right? Instead of saying 0 or 1, we can say it is either 1 or 0 because there is only 2 digits. So the chance of error is more with the machine language. If you want to write the program in the machine language, then there could be number of errors possible. For example, for Intel 8051 to add the contents of register A and register R7, the binary code is 0010 and 1111. It is 2FH. To move the content of register R7 to register A, the binary code is 1110 1111. It is the last 2 in the particular binary digit represents, it's actually the base 2. It is actually the base 2, that is it is representing the binary data. You may be thinking that I'm not reading the last 2, that is the LSB bit 2. It is actually not the LSB, it is the subscript representing the base of that particular data, that is a base 2. That means it is a binary data. Okay, so the first data 0010 and 1111 is 2FH, and the 1110 is EFH. Thus, by observing the 2 examples, it is very difficult for the programmers to write a program in machine language. However, this language is preferred for simple programs and control applications where less computation is required. So for simple programs, this is very good, this is very sufficient. If we write directly in the machine language, then the assembler, we don't need the assembler or compiler to compile the same to transfer the same to the machine language. Directly we are writing in the machine language, so we don't need these extra softwares and extra work for the processor. If we write in the mnemonics, that is in the common tongue, then it has to be converted into the machine language so the machine can understand and process the instructions. Then it will take some time, so it will be less faster compared to the machine language instructions processing also. The characteristics easily understood by the computer system. Yes, the language we are writing, this machine language, is the language of computer that it can understand easily. Very fast in execution and no need of hardware or circuits or compiler or assemblies, right? because we are directly talking in the computer language, writing in the computer language, so it can easily access that. Fast execution is possible because no need of extra hardware to convert this language into machine language, and the compilers, assemblers, or the software part. Difficult to write and understand. Difficult to write and understand because we humans cannot remember those many bits without errors. We cannot reproduce them without errors. Difficult to debug. Yes, debug means detecting the errors. Detecting the errors after we have written the code, then if there is a error prone, that means while compiling, if it shows some error is there in the syntax error maybe, or execution error, or some instruction format error, then the identification of that error will be very very difficult and very slow to enter. Yes, because it is not our language, that is the human language. We should type only zeros and ones, double zero double zero. If we want to write 8 zeros, we will keep on checking whether we have typed 8 zeros or 7 zeros, 6 zeros. So, and the counting is also very very difficult, not readable. Yes, this is also not readable, machine dependent. It depends on the machine, particular machine we are using. This language depends on the machine. And next is the assembly language. So till now we have seen about the machine language, that is zeros and ones will be there. It is also called binary language because only 2 bits are used. We have to memorize the hundreds of instructions, binary instructions, if we want to write a code or process. This task is difficult and error prone, and we have given an example, that is adding the contents of register A and register 7 with the binary code of this particular instruction 0010 and 0011 the hexadecimal equivalent. So with that simple example we can see it is very difficult, but it has its advantages because it is fast in execution. At the end of the day you will see whether the work has been done very fast or not. It is easily understood by the computer, but some more disadvantages are there compared to advantages, because difficult to write and understand, difficult to debug, slow to enter, not readable, and machine dependent. So we have seen the first type of this programming language, that is machine language. Now we are moving on to the assembly language. A program written in mnemonics is known as assembly language program. Program written in terms of mnemonics. So what do you mean by a mnemonic? Mnemonic is a group of alphabets which suggest operation to be performed by that instruction. Right? A mnemonic is a group of alphabets. Alphabets in ABCD, what we are learning in the day of in the everyday's life. ABCDs of English alphabets. It is a group of alphabets which suggest operation to be performed. A few examples are add for addition, XCH for exchange, and MOV A comma RN for transfer data from register RN to accumulator. So these are some of the examples of mnemonic. Observe the mnemonics, that is ADD, add. Yes, add we know it is because of addition, adding, addition, but we are writing only ADD. And for exchange we are writing XCH, exchange, the word for the exchange word we are writing XCH. And for the moving of data from one place to another, we are writing MOV. And observe all these are in the capital letters. capital English letters. Yes, they have to be written in a capital letters only. And if we see the instruction move a comma rn, we have written with some space, with a comma, and again with some space and rn. The spacing, the commas, they have to be followed correctly, otherwise there will be syntax errors. So but for a particular instruction there will be the instruction format, syntax of the particular instruction will be there, and we have to remember it, we have to practice it, and we have to write in the same way. It has to be written, then only it will be executed. Otherwise until we are correcting that particular instruction, that means we have to debug. Bugs has to be eliminated, identified and eliminated, then only it will be executed. Now the third para, the writing of program in assembly language is much easier as compared to the writing of a program in machine language. Yes, because in the machine language what we have used only the two digits, that is either 0 or 1 only, and if we use those two digits only, we cannot remember the entire instruction in that binary data, and we cannot reproduce it without errors. But in case of assembly language, see the example move a comma rn, that is our common language, common English language, so it will be easy, very easier to remember it, easier to rewrite it, and without any errors we can reproduce it. The machine and assembly language instructions are specific to each microcontroller. Yes, each microcontroller will have some special instruction, special machine language will be there, but the mnemonics will be are of transferable. These machine languages are not transferable to other microcontrollers, and sometimes it is also called as one-to-one language, since each mnemonic refers to unique operation. Each mnemonic is unique. The characteristics is easy to read, very easy to read, easy to debug, because we can detect the errors. That is, if we write some error in this particular instruction move space a comma space rn, instead of that if you write move a space comma and without space we have written rn, that will show error at that move a space. If the cursor will be blinking at that particular point, then we can detect that there is a error in that instruction, and we can compare with the syntax of this particular instruction. We can easily edit that, and we can remove that particular error. And easy to write, yes, it is a common term, so we can simply type on the keyboard. It is not portable, that is, the programs written for one microcomputer cannot be used for any other, because each computer has its own assembly language. This each assembly language is different from that of other assembly languages of other computers. It is a machine dependent. Each machine will have different assembly language. In this particular 8051, we may call the movement of data from one register to other as MOV. In the other microcontrollers, we can use the, instead of MOV, it may be copy, COP, or something else may be there. That is the work of designer, that is the will of designer. If he or she who manufacture that microcontroller, who design that microcontroller, if he wants to use some other language instead of English, they can use other languages also, German alphabets, Russian alphabets, even Hindi. Yes, if you want to use, yes, if you are the designer, then it's your will. You can use the assembly language of your own. The sixth point is it requires assembler to convert it into machine language. Assembler, it's a software. It means it will convert the assembly language into machine language. So these are the characteristics of assembly level language. That is, a program written in mnemonics is known as assembly language program, ALP. Simply we can call it as an ALP. And mnemonics is a group of alphabets which suggest operation to be performed by that instruction. A few examples are add for addition and XCH for exchange, and MOV space A comma RN for transfer of data from register to accumulator. Writing a program in assembly language is much easier as compared to the writing of a program in machine language. The machine and assembly language instructions are specific to each microcontroller. They are not transferable to other microcontroller, and sometimes it is also called as one-to-one language, since each mnemonic refers to unique operation. And these are the characteristics. Now moving on to the next computer language, that is high level language. If you see the characteristics of this machine language and assembly language, there are some advantages and disadvantages. So to remove those disadvantages, we are going for the high level language. The disadvantages of assembly languages are overcome using a high level languages. Instructions written in high level language are called statements rather than mnemonics. In a high level language, statements more clearly resemble English and mathematics than mnemonics. So instead of mnemonics, we will use directly the English words. It may not be a total word, but it is very similar to the entire word of this English, and that's why we call it as those instructions as statements in this high level language. Examples: Fortran, Basic, COBOL, C, C++, Pascal are some of the examples of high level languages. Programs written in this language for one type of computer can easily be used for any other type of computer. That is portability. Portability is there because we can use the same program for multiple machines also, because the programs written in high level language are portable. The programs written in these languages are easier and faster because one statement of high level language corresponds to too many instructions of assembly languages. So that is the possibility here, because assembly language we have to write instruction by instruction. But in the case of high level languages, those multiple instructions can be combined and can be written in a single high level language statement. The program written in high level language are converted to machine level before executing them. The programs written in high level language are converted to machine level before executing them. So they have to be converted into the machine level. This is done by either compilers or interpreters. So compiler or interpreter is the software which will convert this high level language directly into the machine level language. In the previous slide we have seen about the assembler. That is, assembler will convert the assembly level language into machine level language. So see the definition of a compiler: a program that translates a high level language program into a machine language program is called a compiler. Compiler is more powerful than assembler. Program that translates a high level language program into a machine language program is called a compiler. And interpreter, it is also a translator. Translate a high level language program into object codes statement wise. It does not translate the entire program at a time. It takes up one statement of a high level language program at a time and translate it and then executes it. It is slower than a compiler. So the compiler will convert the entire high level language into machine level language at a time. In the case of interpreter, it is taking only one statement, that is one line at a time only. So it is slower, but the error detection is possible and high in case of interpreter. Though it is slow, the detection of the errors is, that is the debugging process, is very efficient in this interpreter compared to compiler. Now see the difference between a high level language and low level language. A high level language, it is a programmer friendly language. That means we user can easily understand and easily write, easily remember, easily debug. That is a characteristics of high level language. In case of low level language, it is machine friendly. That is, machine can easily understand that. Machine can easily process that language. That is the low level language. Next, second point is high level language is less memory efficient. So it uses the less memory because multiple instructions can be written in a single statement. And in case of low level language, it is high memory efficient. Efficient means it will use the memory efficiently. That means properly. It will not waste the memory. So low level is the most efficient language, memory efficient language. It does not need the compiler or interpreter to convert into the other language. So it will takes less time to process. It is a faster. In the high level language, the third point is it is easy to understand. Yes, it is. We humans, that is users, can easily understand. We are called programmers. In case of low level, it is tough to understand. And the fourth point is it is simple to debug. Simple to debug. You can easily identify the bugs, that is the errors in this high level language, and we can eliminate them easily. Detection is also easy and elimination, that is correcting them, is also easy. It is simple. And in the case of low level language, it is complex to debug comparatively. Comparative means compared to this high level language, it is complex. in case of low level language. And in the high level language, it is simple to maintain. So we can store the language easily, and we can edit them program easily. We can change the instructions, and we can improve the code also in the future. It will be very easy if you write in that high level language. The others, not only the programmer, but others whoever reads those high level language is can also easily understand. The users, other users can also easily understand. But they can understand what we have written, how the process is going on, what are the inputs, what are the outputs, what is the purpose of the program, also they can easily get. In case of low level language, it is complex to maintain compatibility. That means if there is a slight change in the supply voltage or any electronic components voltage or current, that is relative fluctuation in any block in the entire microcontroller, then there is a change in any one of the bits of this low level language, then we cannot easily identify them, and we cannot easily debug them, because it will simply change from 0 to 1 and 1 to 0. Whether in case of high level language, if it changes like that, if there is a fluctuation in the equipment, if there is a change in the high level language, that is any of the bit is changed from one letter to another letter, then we can easily enter, because we know that language, we are speaking the language in the day-to-day activity. So we can easily, our eyes, our brain can easily detect that error. But in the case of machine language, it is very difficult, and we cannot even know whether that error is occurred or not. So we have to see the entire course of the program, and some of the errors will be detected after the execution also. Yes, they can be executed, because if the data, the input data is changed, we will not get the expected output. If the output we are expecting is not available, then we will think of what went wrong in the program. Then we will keep on checking that each and every point, each and every bit, each and every line. It will be a tedious work, it is tiresome, it is difficult. So that is in case of low level language. For a high level language, it is portable, that is machine independent. We can use the one language on any number of machines. It is not portable in case of low level language, that is it is machine dependent. We cannot use the same low level language for one machine to another machine. It can run on any platform, that is any software. It is machine dependent in case of low level language, and it needs compiler or interpreter for translation. It is into machine language. If you want to convert them, then we need other software and hardware also. But in case of low level language, it needs assembler for translation. It needs assembler for translation. Assembly level language needs assembler language. If you directly write in the machine level language, then we don't need even the assembler also. So those are the differences of between high level and low level language. And still there is another topic, that is the difference between machine level and assembly level programming. This topic we can see in tomorrow's video lesson. We have already completed 45 minutes of class of the second chapter. So please revise these topics whatever we have discussed today, though they may be easy compared to the first chapter, that is we bit byte nibble and words and the machine language. Some of you have already uh, know these words and definitions also, and we will see the next objectives in the tomorrow's class. So I'm closing the today's lesson. Thank you one and all.